All right, if you're getting ready for your boards, you know that acute leukemias are a huge topic. So think of this as your high-yield rapid-fire review. We're going to lock in those key facts you absolutely need to nail these questions. Let's get right into it. So here's our game plan. We're going to start with the single most important number for diagnosis. Then we'll break down the two main types, hit all the classic buzzwords you need to know, decode the genetics that tell us about prognosis, and then wrap it all up with a power-up summary of the exam essentials. Okay, first things first. Before we can get into the nitty-gritty, we have to know what actually makes a leukemia acute. There's a very specific definition. On any exam question, you've got to know the threshold. There's one specific percentage that is the absolute definition of an acute leukemia. Any idea what it is? Think about it for a second. There it is, greater than 20%. Seriously, this is a non-negotiable, super high-yield number. You absolutely have to commit this to memory for your exam. And that's the whole story right there. An acute leukemia is defined by having more than 20% blasts in the bone marrow. That is the gold standard. It's the diagnostic line in the sand. So here's what's really happening. It's a cancer of the baby blood cells, right? These immature blasts, they just start growing like crazy, and they literally crowd out all the normal healthy cells in the bone marrow. This complete takeover, well, that's exactly what causes all the classic symptoms we're about to talk about. This slide, this is your classic board question vignette, right here. You get a patient who shows up with fatigue, easy bruising, and a fever. You check their labs, and boom, pancytopenia. That means all their cell counts are in the tank. Then you see blasts on the peripheral smear. This whole picture should be screaming acute leukemia at you. Okay, so we've defined acute leukemia. The very next question always is, which of the two major paths are we dealing with? Is it myeloid or is it lymphoid? You know, the single biggest clue you will ever get on an exam is the patient's age. It's a massive giveaway. If your patient is an older adult, you have to be thinking AML. If it's a child, your brain has to go straight to ALL. Here's a super simple way to remember it. ALL affects the little ones. Honestly, just knowing that one detail can often get you halfway to the right answer. Let's talk buzzwords. This next part is a rapid-fire review of those pathognomonic findings, those classic clues that just scream either AML or ALL on a test. This is the stuff you've got to know cold. So remember how we said those blasts were taking over the bone marrow? Well, here's the direct result. When there's no room for platelet production, you get bleeding. No room for red blood cells, you get anemia and fatigue. And no room for your infection-fighting neutrophils, you get neutropenia and really dangerous infections. This triad is a direct consequence of that bone marrow failure. Now, for AML specifically, there is one finding that is totally pathognomonic. And what that means is, if you see this on an exam, you can confidently click AML and not even think twice. And here it is, your number one buzzword for AML, the hour rod. It's this pinkish, needle-shaped crystal made of fused granules, and you will only, and I mean only, find it inside a myeloblast. It is the microscopic smoking gun. I'm going to say that again because it is just that important. If the question mentions all rods, the answer is AML, period, end of story. It definitively rules in AML and rules out ALL. You have to lock this one in. Okay, so if our rods are the key for AML, what's the equivalent for ALL? There's a very specific marker that tells you, hey, you're looking at a lymphoblast here. And that marker is TDT, or terminal deoxyribonucleotidal transferase. It's a special enzyme that you'll find in immature B cells and T cells, but you will not find it in myeloblasts. So a cell that's TDT positive, that's a lymphoblast. This is your key lab buzzword for ALL. All right, you've made the diagnosis. You know if it's AML or ALL. The next critical step, both for real-world medicine and for your exam, is figuring out the prognosis. And these days, that is all about cytogenetics. And when we talk about genetics in leukemia, there is one subtype that is so unique, so important, and so testable that it basically gets its own category: acute promyelocytic leukemia, or APL. This is a guaranteed board question. I promise you'll see it. The translocation T1517 is the unique genetic signature for APL. This swap creates a fusion gene that we can target with a specific drug, all-trans-retinoic acid, or ATRA. And because of that, APL is actually a highly curable leukemia. You have to know this triad: T1517, APL, and ATRA. So let's look at the bigger picture for prognosis. For AML, the good genetics include translocation 821 and inversion 16. The unfavorable markers, the bad guys, are things like an FLT3 mutation or losing chromosome 5 or 7. Now, for ALL, hyperdiploidy, which just means having extra chromosomes, that's a good sign. But hypodiploidy, having too few, or seeing that T922 translocation, those are both unfavorable. Let's just highlight that last one because it's super high yield. The Philadelphia chromosome, that T922 translocation, you probably know it from CML, right? But when you see it in a patient with ALL, it's actually a really poor prognostic sign. And it means you have to add specific targeted drugs called tyrosine kinase inhibitors to their treatment. Okay, let's bring it all home now. We're going to wrap this up with the main goal of treatment, and then a final rapid-fire summary of every single thing we just covered. This is your last-minute cram sheet. All right, time for the PANCE power-up. Let's lock in these essentials. Ready? Diagnostic criteria: greater than 20% blasts in the bone marrow. AML buzzword: our rods. ALL buzzword: TDT positive. Key demographic: ALL is for the little ones. AML is for adults. The signature for that special subtype, APL, T1517 translocation. A poor prognosis marker in ALL, the Philadelphia chromosome, T922. And finally, the classic hallmark finding, pancytopenia with circulating blasts. You got this. So let's end with this thought. We just saw how understanding one single genetic marker in APL led to a targeted cure. Now that we're learning more and more about other markers like FLT3, we're really entering this new era of personalized medicine. The very genetics we're using for prognosis today, you can bet those are going to be the treatment targets of tomorrow. Thanks so much for joining me.